internal and external environment. Then it integrates the information and then receives and generates a response. As we know, there are three major areas: the central nervous system, the peripheral nervous system, and the autonomic nervous system. You do not have to know this. This is just an FYI. I think we probably went through this in embryology. The different primary divisions, the subdivisions, and major derivatives of the different parts of the brain. And this is just a sort of a diagrammatic illustration of a fetal brain and illustrating the different areas with the different colors. So does everybody remember all the parts of the brain? Every single part, right? So you may not need to watch this video. Please let it work. Please let it work. This is like my favorite video. Are we hear it?
Yes. Hippocampus, neural node, right hemisphere. Pons and cortex, visual. Sylvian Fisher, pineal, left hemisphere. Cerebellum left, cerebellum right. Synapse, hypothalamus, striatum dendrite. Axon fibers, matter ray. Central tegmental pathway, temporal lobe. White core matter, forebrain skull. Central fissure, cord spinal, parietal. Diameter, meningeal vein, medulla oblongata, and lobe limbic. Electrodes. That ought to keep those squirts happy. Yeah?
All right, now we know the parts. At least the brainstem. All right. And so there are three general features of the central nervous system. It has unique cell types. And what are the different cell types? Can anyone tell me at least one? Neurons. What else? Glial cells. So what falls under the category of glial cells? Astrocytes, oligodendrocytes, and microglial cells. Yes, yes. It has unique function and location, and also it's encased by the cranium. So one of the things that's interesting about the brain is any factors that affect the brain itself, because it's encased within a skull or cranium, that could lead to difference or produce some secondary effects. So the unique cell types, neurons and glial cells, and we just mentioned all of these. The only ones what we didn't mention are ependymal cells, or ependymal cells, depending on where you're from. And where do ependymal cells exist? Where do they lie?
The ventricles.
Ventricles, right? Yes, behind the ventricles. So when neurons undergo death or necrosis, it's often accompanied by degeneration of the myelin sheath. So when we look at demyelinization, we have the loss. So this is a diagram of a neuron, sort of a cross-section. And this is your myelin sheath on the external aspect, and the axon is within the center. So whenever you have neuronal degeneration or death, one of the first things you see is myelin sheath loss or degeneration, and the term we use for that is demyelinization. So neurons are highly vulnerable to injury. So as we age, we have this small neuronal cell death. So as you get older, one of the things that occurs is neuronal loss and neuronal degeneration. So neurons react in three ways. The acute form is due to ischemia or overwhelming acute toxicosis or toxicity. And the neurons are usually shrunken, so they're small. They form triangles or angular and they have bright pink cytoplasm or eosinophilic cytoplasm. This is the most common presentation we see with neuronal degeneration because in a lot of cases it's due to lack of oxygenation to the brain. We do have degeneration that occurs, as I said, with aging and in chronic disorders. And the cytoplasm of the neuron is more blue or basophilic. And you might see lipofuscin accumulation within the cytoplasm. So what is lipofuscin? A what? So it's pigmented, yes, and it comes from dead or dying tissue, and it accumulates, and the brain is one of the common places it accumulates. It can be reversible, but only if you have the nucleus is intact. So if the nucleus is degenerating, undergoing pignosis, you cannot regenerate neural tissue. And then the last one is axonal reaction, and that's when the axons itself are injured. And we talked about that a little bit when we looked at Wobbler syndrome. Sometimes you have degeneration of the axons in those cases. And with that, you get neuronal swelling and loss of angularity. So these are the three ways that the neuron reacts to injury. It could be the acute form, the more chronic form of degeneration, and then lastly is when the axons undergo reaction. Yes?
Did you say degeneration was the most common or was chronic?
Chronic. The acute necrosis is the one we see most commonly. And acute necrosis can be regenerated again only if you have retention of the neuron. So this is an H&E sections of the maybe cerebrum, and to sort of get an idea of where we are. This is a blood vessel right here, so part of it here. And in the blue circle, we have a neuron undergoing acute necrosis. So it's angular, has either a triangle or just an angular appearance. It is eosinophilic or bright pink. And so this is an indication of acute neuronal necrosis. Oftentimes with neuronal necrosis, we have a term we call satellotosis, where we have surrounding dead or dying neurons, we have the accumulation of oligodendrocytes. So they're trying to sort of get rid of this dead and dying neuron, and they start to surround the neuron, and the term is called satellotosis, kind of like satellites in space are constantly in orbit. So this is neuronal necrosis, and this is satellotosis. And as we see, we have a number of degenerating neurons on this picture. Yes?
Can you repeat what you said is surrounding the neuron?
Oligodendrocytes. These sort of dark blue cells, they look like lymphocytes, but those are oligodendrocytes. Any other questions? All right. Astrocytes, so we talked about them, they respond similar to fibroblasts. So I consider them as the fibroblastic tissue when you have injury to the brain. They start to react. With acute injury, astrocytes become swollen and bright pink. And so when they become swollen and bright pink, they're no longer called astrocytes. They're actually now called gametophytes. So it's important to know this terminology. So swollen astrocytes that have been acutely injured, they're usually deeply eosinophilic. The term we use for that is a gametophyte. So the other thing, sort of similar to fibroblasts, when you have scarring, when you have chronic injury to areas of the brain, the astrocytes start to proliferate and they form what is called a scar or gliosis. So two things you have to know about astrocytes: when they swell or undergo acute injury, they're called gametocytes. When they start scarring or proliferating, they're undergoing gliosis, or another term is scarring. Oligodendrocytes can be present in the white and gray matter. In the white matter, they are found between axons, and their main job is to maintain myelin sheath retention, or keep it well maintained. They do proliferate in early demyelinization, and so in the white matter, one of the functions of oligodendrocytes is to make sure you have sufficient myelin. In gray matter, they usually surround the neuron, and they swell in response to injury. And as I said earlier, whenever they surround a damaged neuron, the term is called cytolytosis. Microglial cells, those are sort of your macrophages, and when they're filled with fat or lipid, the term we use is a Gitter cell. So lipid-laden macrophages or lipid-laden microglial cells are called Gitter cells. So there's a lot of terminology you have to make sure you know when it comes to the CNS system. And lastly, for some reason this is over here, we said ependymal cells, they line ventricles, and they also line the central spinal canal. So obviously, as I said, location and function, it's important that we are aware that the brain is encased within the cranium, and it can affect areas surrounding that area. The cranium protects vital organs, and it can have a space-occupying lesion. So if you have a neoplasia within the brain, it can really have a severe reaction, or the animal can have severe clinical signs, not because of the tumor itself, but of what it's compressing. It's important to know the layers of the meninges, and this is just a diagram showing you the different layers: the pia, arachnoid, the dura mater. Obviously, you have bone, where you have periosteum, and then the skin on the top.
Could you go back a slide to that implications of
Implications? Yes. So the brain encasement, it provides protection, and I was also saying one of the issues, it can cause space-occupying lesions to occur. So a cranium being sort of like an encasement of the brain can lead to clinical presentations. Now we're going to look at some development malformations, and these are pretty unusual, and we do see them here and there, especially more in large animals for some reason, but we can see them in small animals as well. We're not going to do all of these. I think the only ones, we don't do globoid cell leukodystrophy and Arnold-Chiari malformation. All right, so the first one is anencephaly, and is defined as the absence of most of the brain. And in this case, it's primarily the cerebrum is affected. So it's very hard to find any of these pictures in animals. So I have human pictures to sort of show you. So this is a normal infant with the brain stem right here, and in anencephalic animals or infants, you have absence of the cerebrum. So this is a person, child. Yes, question?
Is this PowerPoint uploaded? So what we have is slightly different.
What do you have?
We don't have the anencephaly at all.
You don't have that. What do you have next?
It goes from function location to meninges.
Meningiocephaly. Oh, okay. Let me see here. So you go straight to this one?
Yes.
Okay. I'll have to upload the last one. Alright, just pay attention. I'll put it up there. That's kind of odd. I don't know why. This has been. Okay, so anencephaly, absence of most of the brain, primarily the cerebral hemisphere. And this is showing you again anencephaly in a child. The one picture I find, it looks like a Muppet to me, and I'm not trying to be funny, but it really does. And this is from an article from a dog with anencephaly. I believe it had a viral etiology associated with it, but I can't remember. So we have the eyes, and this is the top of the head. And so he has the complete absence of the cerebrum. It said note also that he has brachygnathia superior associated with it. The next one is A, myelia, and that's total absence of the spinal cord, and it typically occurs with anencephaly. Again, these are real. They don't look real. They look like something I made up. But again, complete absence of the spinal cord. And the term is amelia. What's important to know is make sure you understand what each of these terms mean. Meningoencephalocele, and this is protrusion of the brain and meninges through a defect in the cranium. So every time I say dog, I really believe this is a cat, based on the claws. And so this is the top of the head, and you see a small fleshy mass protruding from the cranium. So there is a focal defect called a cranium bifida. So the defect itself is called a cranium bifida. The protrusion of the meninges and brain through that hole or defect is called a meningoencephalocele. One of the causes is giving cats griseofulvin in the first week of gestation. And so what is griseofulvin used for? Ringworm, yes, it's a treatment for ringworm. So, and this oftentimes this is unexpected. The first week of gestation, you will typically not know that a cat or dog is pregnant. But if you do give that animal griseofulvin through that first week of gestation, it causes that malformation in the fetus. So it's important to be aware of that. Yes.
Limited to the first week, or is it at any point in early gestation?
No, the first week. For some reason, I guess when the development of that certain area in the brain or in the cranium is occurring, this drug, which I really don't know the biosynthetics of it, prevents the complete formation of that area of the brain, the cranium. So kind of like spina bifida. So is anybody familiar with spina bifida? So what is one of the things that they say could prevent spina bifida? Folic acid. So for whatever reason, that nutrient is important to make sure that you have complete closure in that area.
Is this seen in like chihuahuas that are also prone to open fontanelles?
Right. But it's not the same thing. So an open fontanelle is different from a meningoencephalocele. So open fontanelle, they are predisposed, and that's more of a genetic thing with chihuahuas. With this, it's more of formation of the cranium itself. And it's, for some reason, that first week is when it affects the animal. So you want to make sure that you don't give obviously pregnant cats, but that first week they're highly predisposed to getting this particular defect. Yes, Sheridan?
Did you say the cranium bifida is another name for this?
No, wait.
It occurs with.
So the cranium bifida is the hole or the defect in the cranium.
Okay.
And meningoencephalocele is when you have protrusion of the meninges and the brain through that hole. Yeah. And obviously we took the skin off, and you just see a little nodular mass on the top of the head. In most cases, you might not be completely sure of what it is. Okay, so I'm going to scares me. It's kind of loud. Whoever fixed the speaker, thank you.
There's a question.
There's a question, yes.
I don't know if you can answer or not, but I remember with Dr. Egram, we had a picture of, I think it was like a human baby, and I think like the whole brain that basically like came out of its head, it was still in the skin.
Wow.
Would that be considered the same thing? It was like a humongous like bulge on the back of the head.
So if it doesn't have the meninges over it, it's called an encephalocele.
Okay, yeah.
So when the meninges are over it, so there are three things that you can get when you have protrusion of stuff through a hole. You can get a meningocele when it's just the meninges protruding through. Meningoencephalocele when both, and then encephalocele when you just have the brain popping out of a hole.
Oh, I think that's what it was.
Oh, cool. I'm so proud of her. That's anatomic pathology. So ClinPath and anatomic path, yes, we're in the same family, but we don't like each other because we feel we're better than they are, so because we are. But anyways, yes, time for the game. Now it doesn't make any sound. So turn it off. Alright. The first person knows how to do mosaics. And she sent me actually some, I was totally impressed. I'm even putting in my order today because I want something on my wall. So this is one.